Hello, welcome to the Department of Materials Science and Engineering. I'm Dan Blackwood, the Deputy Head for Education and Student Affairs. You may be wondering why there was a picture of a helicopter just now on the first slide. Well, helicopters are made out of materials. We're trying to make better, lighter materials, stronger materials. And my hometown back in England has built military helicopters for over 70 years. So obviously I have an interest in helicopters. But what is materials science and engineering? Well, it's that bridge between the traditional sciences that you would have done in high school, things like physics, chemistry, and biology, and then we put engineering into it, where you're going to use it in places like robotics, renewable energy, sustainability, and a whole lot of other industrial applications. Look around you. You will see materials everywhere. Your computer screen, it's transparent, but it's also conducting. How do you make that? We make transparent conducting oxides. Maybe you've got a battery-powered bike. That's made from lithium materials. Again, that's important for MSE. Maybe you might have some braces in your teeth. There we use shape memory alloys. Or there's a health tracker in your arm, perhaps. That, again, relies on piezoelectric for materials. It's materials that are shaping the world around us. And we will continue to do that. We're looking for better materials for the MRT systems and train systems. We're using quantum dots to help against forgery. And even in cosmetics, an area where you might not expect a lot of material science and engineering, there are new graphene sheets are being used there. And what about the future? If we go to nano robotics, we're going to need materials. And what about transparent camouflage? There are actually materials that can bend light so it looks like it's transparent and not there. And maybe even colonizing Mars. We need to get water from the atmosphere to colonize Mars, and I'll say a little bit more about that in a moment. Our own research in the department, we have Professor Ben T, who's developing piezoelectrics to test the pressure of eyes in patients. Professor Daria works on 2D stent materials for heart patients. We have Wei Beng, who works on absorbable bandages, who won a prize for Johnson & Johnson. And then we have Professor Wu Chen-sen, who is developing sensors to look at the blood flow in babies just after birth. So you can see that material science is important in the area of biomedical. We also have colleagues like Professor Tan Sui Chin. He is looking at materials that can absorb water from atmosphere, which is very important in Singapore where we have water shortage. And it was his project that was picked up by NASA for looking at colonizing Mars. How are we going to get water on Mars? And then there's Professor Wang Qing, who's looking at recycling batteries. We know that we're going to go towards batteries like lithium, but there's not enough materials to use those batteries unless we can efficiently recycle them. And Wang Qing has just set up a startup company for that. And what about for the future? Well, Professor Kosnia is heading a new institute on functionalized intelligent materials, which costs $200 million, $100 million from NUS and $100 million from the government. That shows you how important both the government and NUS sees material sciences for the future. Then there's Professor Barbaros and Professor Ahmed, who have developed black phosphorus, which is going to help make better spintronics. Spintronics are going to be used in the future for transistors, which are obviously the basics of all the semiconductor industry. And then Professor Turo works on fibers, and he's using those fibers for biomedical robotics. What about yourself? What will your journey involve? Well, in your first year, you'll predominantly do the foundation. So we'll build more on your maths, physics, chemistry that you've done before, but also things like project management. And then as you go into the second year, the curriculum will deepen. As you'll do the core material science subjects, you'll learn about the mechanical properties, the chemical properties, and the electronic properties of materials. And then when you go on the third year, you'll have an industrial attachment. And also maybe have the opportunity to go overseas. More than half of our students do go overseas for a semester. And in your final year, you'll do deeper areas in material science and engineering, and you'll do your final year project plus specializations. So what specializations do we actually have? Well, we've actually got 6 specializations. The first one I'll talk about is biomedical materials, where we came together with the Department of Biomedical Engineering. And a typical example of where material science and engineering is used in biomedical industry would be drug delivery, smart drug delivery. What you want is the drug is to slowly release the drug so that it will give the patient the right dose all the time. But that slow release is actually a material science and engineering problem. And indeed, we use exactly the same technology on the bottom of ships to stop barnacles attaching. If a ship badly fouls with barnacles, it burns twice as much fuel. And what that shows is that in material science and engineering, we're interested in the entire dimension range, from the nanomaterial size of the biomedical industry to the meter size of the bottom of an oil tanker. Then we go on to renewable energy. We have a specialization in renewable energy and sustainability. Renewable energy involves batteries, which we have a lot of research on, solar cells, and water harvesting. And then there's microelectronics and quantum materials, where you'll concentrate on the electronic properties of materials, such as the black phosphorus being developed by Prof. Barbaros to improve spintronics. You also have the opportunity to join the robotics. That's a faculty level specialization, but material science students can be involved in there. You might think, well, where are materials in robotics? Well, if you wanted a robotic to pick up an apple, it needs to be able to pick up the apple without squeezing too hard and breaking it, or not have enough pressure. It wouldn't be able to pick up the apple. So we use piezoelectrics there. But actually, those piezoelectrics are exactly the same as what Ben T uses to test the pressure of eyes in patients. So you can see that in material science and engineering, we take the properties of materials and use them across all the traditional engineering disciplines. And then there's artificial intelligence. We're going to be designing materials for the future, where we're going to design them bottom up, like the New Institute by Kostner. But also you need to know how to use artificial intelligence to choose the right material for the right application. And then we have nanotechnology. Nanotechnology is like quantum dots for the displays. Why come to NUS? Well, to be honest, I think the most important reason to come to NUS to study material science and engineering is we're the only comprehensive university in Singapore. So when you come to NUS, you get to mix with students from economics, law, social sciences, and you'll build up a network. And that network that you build up will stay with you for your entire life. So that can only get given to you at NUS. None of the other universities in Singapore have that. But perhaps more specifically at MSc at NUS, we take a small cohort, so we have a very good student-to-staff ratio, and we get to know all the students. We've also started making an emphasis on women in MSc. We need to get more women to engineering, otherwise we're essentially wasting half of our population, and Singapore can't afford to do that. We will also give every undergraduate a mentor. This is someone that you can go and talk to and discuss not only your academic situation, but any problems that you have during life. We know that young people do have a number of issues, and it's useful just to have a friend that you can talk to in confidence. We also have strong partnerships with industry, which will help you get employment, and that's obviously important to you in your future. An example of how we've got good industry contacts is our students have gone to visits to places like 3M, Global Foundries, and ST Engineering. So these are times when we've taken our classes around the factories, and because we're a relatively small cohort, that's practical. If we had 300 students, the companies wouldn't allow us to take all our students. Where we're only around 50, 60 students, we can do that. We also took a group of students on an exchange to Thailand, a cultural exchange. Where might I be able to go to work is obviously something you're going to think about. Well, our students sort of go everywhere. The materials companies that I just mentioned, like Bosch and 3M, they also go into the chemical engineering sort of side on the refineries, places like Shell, Esso. They all have issues such as corrosion, which is my own specialized area. The aerospace is a growing area, Rolls-Royce and Bombardier. Then we go into the energy area. There are battery people, and Keppel is also an area where they're growing in material science and engineering. And I'm afraid a few will go off to banking and even into the tax. The reason they go there is the analytical thinking skills that you'll learn while you're at us at NUS are excellent for passing the professional exams in the banking and accountancy sort of areas. These are a few of our more recent students. Ian Sim has just started on the Duke Medical Program. So he finished with us within 4 years, and now he's going to go on become a medical doctor through the Duke program. Jeremy Coe, he is now head of Advanced Materials Solutions and Solder Systems at ST Engineering. And he's also an adjunct assistant professor with us in our department. And then there's Jay Singh, who graduated in 2018 from her undergrad and then did her PhD with us. She's now working at Procter & Gamble Innovation Center. And we also have our own study award, which will come with no bond, and it's actually competitive with the university level awards given by some of the other universities. So this is to attract top students into our department. Then I'm going to finish with a quote by Elon Musk. I know he's a controversial figure, but one thing he does know is how to take technology and turn it into money. And what he had quoted was, "Take Material Science 101, you won't regret it." If you would like to find out more, you can scan these codes. You can find out more about the department or about the open house that is coming up soon. Thank you for listening to me.